Hi, this is Grace reassessing for standard. I think it was I think it was 6.7. I'm not sure. It was the one about thermal energy. I used problem 31 in chapter 7, and here's the problem. Um Here are all the constants that were given in the problem, and I just converted Celsius to Kelvins because like that's what we are gonna need in our calculations. So I just put it here, so it's easier for me to see. Um, for A, I kind of like at first I considered the water and the aluminum pan as two like things because they have different masses, temperature, and heat capacity. And I realized that that the heat goes from the water into the pan. Of course, that's under the assumption that like every bit of heat or delta E therm is like not lost in this process. So I went on and assumed I set the final temperature as X and used the equation mc delta T on both sides and equated them, and I solved it. So the final temperature turned out to be 332.039 kelvins, which is 58.889 Celsius. For part B, well, obviously 1 and 2 are incorrect since the temperature of both the water and the pan changed, so their thermal energy can't stay the same. However, we did make the assumption, as I said before, that like all the energy that's transferred between the two was like not lost in the process. And for 4, I actually didn't realize that the capacity could change, but I guess it could. But in the settings, I just assumed that they were constant, which is why like the I didn't change them in the calculation process. I mean, that would also make the problem a lot more complicated. For part C, ignore that. That was just me trying to figure stuff out. But I thought that the change in thermal energy in the water and the pan would come from the work from the person beating the pan, as well as the stove heating the water. And since we could and like here I calculated the delta E therm for the water, and here's the delta E therm for the pan, and we know how much work the person did, so this is the only unknown variable in our equation, and I just went ahead, did the calculation, and solved for it, and it turned out to be 18,105.711 joules. Thank you.